after, I'll talk about data infrastructure. Right? We've heard the speakers talk about real-time data and the need for organizing this data and making it actionable, but really kind of how it plays into the smart manufacturing platform, as well as kind of playing into preparing the data so we could use more sophisticated models and tools and things, right? So I'll use some company information, right, to set the context. And OSIsoft's been a software company for over 34 years, and we've had a very singular focus on that real-time data infrastructure. That's what we do. We don't write applications. We don't sell hardware. We focus on high-fidelity, real-time data. And our founder is a chemical engineer, and our company it's really a software company run by engineers, chemical engineers predominantly, even though I'm a mechanical engineer. And again, but the other thing is that 65% of the global Fortune 500 use Pi, our Pi system, and we have 16,000 sites. So, to address the whole legacy discussion, right? We don't just move on to newer technology. We actually have customers that have been with us throughout the whole journey, and that's important to us. But now the industries that we're prevalent in. So we're ranked first in terms of kind of the power generation in the U.S. I think it's about 60% of the power generated is running Pi for this real-time data monitoring. 100% of the oil and gas top 10 producers, 40 out of 50 in the chemical space, metals and mining. But there's some developing areas as well in terms of like data centers and smart cities and connected services. And the reason that I share this with you, the point of interest, and I think Denise we talked about this, was around we're living on both sides of the meter, right? We've been working on the real-time operations side, not only on the generation side and the power side, right? The generation, renewables, nuclear, also the transmission and distribution. We're in 100% of the independent system operators, right? The ISOs in the U.S. as well. And so on the other side of the meter, we're also on the big consuming side of it as well. We've been working in real-time operations in some of those manufacturing verticals as well. So what's interesting is we've been living on both sides of the meter. And what we talk about is we talk about an infrastructure, right, on both sides where they can continue to build on their investment for this data infrastructure. So I think we talked about these vertical solutions. Our philosophy is around a data infrastructure and continuing to build solutions on there, whether it's for energy or asset optimization or performance management, is we want our customers to kind of keep building on top of that infrastructure, which I think lines up very nicely to the SMLC discussion, right? It's an additive type of discussion, and also kind of, like I said, not leaving our legacy install base behind. One of the other things about our philosophy is around data collection. And can't tell you how many times we talk to folks that say, we collect all of the data. It's like, I'm sure you do, right? At what fidelity, right? When you sample at those kind of frequencies or you average, you miss all the good stuff in between, right? That's really where the devil's in the detail of that higher fidelity data. And so that's something we're very, very conscious of in terms of capturing that high fidelity streaming data. So to describe the way we look at it, right? Traditionally, we were seen as a historian, which is taking kind of sensor data and storing this data, right, and historizing. But now we realize the importance of understanding contextualization, right? And I know the question was around the contextualization when you first capture it or after the fact, but we recognize that it's the marriage of that real-time temporal data and that contextual data, right, throughout the architecture, right, so that you can draw these insights. So I'm really focused on how our operational customers use these data, right, to drive the actionable intelligence, right? So these more advanced tools. The other piece is around events. Either anomalies in the data, or what's interesting is we like looking at all that streaming data, but we actually start doing something we call an event frame. We start looking at the start and the stop during that period, right, and associating that as a piece of data. And I think this is kind of key into looking at the data in an asset-based way, right? So it's not just taking the starting and the ending point, but looking at that stream of data and relating it to certain events. And I think this is some pretty cool capability kind of moving forward. I'll give you an example in terms of equipment vendors and obviously turbines, and looking at kind of real-time sensor data at the inlet, at the exhaust of a piece of equipment, let's just say, right? Temperature and pressure data, but bringing that asset contextualization, right, in terms of information about the asset, bringing information about its operating pattern in terms of performance curves. And now you start seeing kind of that temporal data with the contextual data coming together. And what you start doing is you start doing some of these calculations, right, to drive to these key performance indicators that wind up driving these notifications, right? So this is kind of the devil in the detail of how the data kind of moves from the sensor to something that starts kind of being business driven, right, in terms of driving business value. So this is some pretty interesting capability that'll be generally available probably towards the end of the year. We've been working on something called Pi Cloud Connect. So I talked about the two worlds, the operational side, and I talked about the producing side. But we recognize that facilitating that exchange of data using a cloud kind of abstraction layer, facilitating that data exchange brings value throughout the whole value chain, right? So we're all for the exchange of data. So it's contextual data, contextualized real-time data, and being able to exchange to do things like demand response or facilitate optimization of the value chain, like in the General Mills example that Jim discussed. Now this is my density slide. I apologize.
You got on me this morning.
Yeah, you got on me this morning. And the reason I share this one with you, this one just kind of shows, great, we're living in the operational world, right? We've got data coming from sensors and legacy SCADA controllers, distributed control systems, coming through, and obviously we're serving our operational users, the operational technology side of the world. But we recognize that now more sophisticated modeling and more sophisticated analytics need to be enabled. And we kind of we have a project called DataCast, where we aggregate, cleanse, transmit, and shape some of this data to enable it so that we can leverage some of these more analytic tools, right? These more advanced analytic tools, like in the case of the universities or the work that my colleagues have discussed. So it's not just kind of furnishing that to feed the model, but it's the output of the model that comes back into the operational world, right? It's that closed loop piece, right? And this is where I think our interest in the SMLC comes in, which says, hey, we want to bring that data into a platform where the data is organized. We want to use these powerful tools, recognizing that there's many of them and they'll evolve over time, and then be able to bring that output back into the operational world. So that's what really focusing on that narrow piece of the data infrastructure means to us. So here's some interesting capability that's also kind of coming in the next year or so for us. Is traditionally we've taken that output data and you can compare it historically, right, to see how you've performed relative to your model. And that's great, right? You can test the accuracy of the model and you can tweak some of the parameters. But there's some interesting capability where you take that model output and you start forecasting it out. And we kind of use the term future data, which sounds a little unusual. But now, the ability to say, gee whiz, we can actually model out and identify where the operational pattern is going to digress or trigger a different action or another look at the models. So this is kind of extrapolating out that model data and being able to identify future improvement, right? Not just looking backwards at the historical piece. So in terms of our involvement with the SMLC, obviously we're working within the SMLC platform and leveraging our Pi system, our real-time data infrastructure in that environment, but also leveraging back that data exchange capability that we leverage, and that one happens to run on Microsoft Azure cloud. So to Jim's point of clouds to clouds talking to each other, we're working with that as well. And we're also working with the test beds in terms of how to get that data into the cloud, how to enable the model, how to bring it back into operations, and how to exchange it throughout the value chain. So that's the uncool part of our story, is actually the data. Again, if you're interested in more about Pi, we're headquartered here in San Leandro, and again, we'll be here for the Q&A discussion, but I'd love to talk to you some more about it as well. Thank you.